Imagine two people holding identical clocks. One stays on Earth, the other flies near the speed of light, or gets close to a black hole. When they meet again, something impossible has happened. One clock has moved slower than the other, not because it was broken, because time itself moved differently. This is called time dilation, and it is one of the strangest truths in the universe. Most of us think time is fixed. 1 second here equals 1 second everywhere. But according to Einstein, time is not universal. Time is connected to space, motion, and gravity. Together, space and time form something called space-time. And space-time can bend, stretch, and behave in ways our brains are not built to imagine. There are two main ways time dilation happens. The first is speed. The faster you move through space, the slower your time moves compared to someone standing still. At everyday speeds, like cars, planes, or rockets, this effect is tiny. But near the speed of light, it becomes massive. Imagine a spaceship traveling at almost light speed. For the astronaut inside, everything feels normal. Their heartbeat feels normal. Their clock ticks normally. Their thoughts feel normal. But to people watching from Earth, the astronaut's time appears to slow down. A journey that feels like 1 year for the astronaut might be many years for Earth. This is not science fiction, it is physics. The second type of time dilation comes from gravity. The stronger gravity is, the slower time moves. Near Earth, time runs slightly slower than it does in space. Near a neutron star, time slows even more. And near a black hole, time can become extremely distorted. If you could safely hover near the edge of a black hole, called the event horizon, time for you would pass much slower compared to someone far away. To them, you might look almost frozen, but from your perspective, your own time would still feel normal. That is what makes time dilation so mind-blowing. Nobody feels their own time slowing down. Everyone experiences their own clock as normal. The difference only appears when two observers compare clocks from different places, speeds, or gravitational fields. This effect is not just theory. Modern technology already depends on it. GPS satellites orbit high above Earth. Because they move fast, their clocks are affected by speed. Because they are farther from Earth's gravity, their clocks are also affected by gravity. Engineers must correct these tiny time differences. Without these corrections, GPS navigation would slowly become inaccurate. So every time your phone gives you directions, it is quietly using Einstein's universe. Time dilation also changes how we think about space travel. If humans ever travel close to the speed of light, astronauts could experience much less time than people back on Earth. They might return home only a few years older, while decades or even centuries have passed on Earth. This creates one of the deepest questions in science fiction and real physics. If we master extreme space travel, are we also learning how to travel into the future? Not with a machine that jumps through time, but by moving so fast or entering such extreme gravity that the universe lets your time run slower than everyone else's. Time dilation tells us something powerful. Time is not a giant clock ticking equally across the cosmos. Time is personal, flexible, relative. Your motion matters, your gravity matters, your place in the universe matters. And somewhere near a black hole or inside a spaceship racing between stars, 1 second might not mean what you think it means. So the next time you check the time, remember this: the universe does not have one clock, it has billions, and not all of them tick at the same speed.